The solar tempest, humanity's hidden vulnerability to the sun's fury. Imagine a scenario where, within minutes, modern life grinds to a halt. Planes are grounded. Internet connections vanish. Power grids fail. Satellites stop responding. This is not the plot of a science fiction film. It's a plausible consequence of something very real and very underestimated: a powerful solar storm. In May 2024, Earth was struck by the strongest solar storm in 20 years. Despite the severity of the event, our planet was remarkably lucky. The storm brought with it dazzling auroras visible far beyond their usual polar homes, captivating the skies of regions unaccustomed to such cosmic spectacles. But while social media buzzed with awe-inspiring photos, scientists and space agencies around the world remained on high alert. Because this storm was just a warning. A giant awakens. AR 3664. At the center of the current solar unrest is an enormous sunspot group designated AR 3664. This region, a swirling maelstrom of intense magnetic fields and solar instability, is 15 times the size of Earth. It has already produced a staggering 75 M-class and 10 X-class flares in a single week, including an X4.5 class flare, which ranks among the most powerful solar emissions ever recorded. Sunspots like AR 3664 are essentially areas of magnetic tension where energy builds up until it is violently released in the form of solar flares or coronal mass ejections, CMEs. These phenomena can hurl billions of tons of magnetized plasma into space, sometimes directly toward Earth. If aimed right, the effects can be profound. In early May, AR 3664 temporarily rotated out of Earth's direct line of sight, providing a brief period of safety. However, this is temporary. The sun rotates on its axis roughly every 27 days, meaning AR 3664 will face Earth again in the coming weeks. Experts warn that it could unleash solar storms comparable in strength to those of the infamous Halloween storms of 2003, or even the Carrington event of 1859. The Carrington event, a warning from history. In September 1859, British astronomer Richard Carrington observed a blinding flash of light on the surface of the sun, the first recorded solar flare. Within 17 hours, Earth was bombarded by a powerful CME. What followed was chaos. Telegraph systems failed, sparks shot from telegraph wires, and auroras were seen as far south as Cuba and Hawaii. Though the world of 1859 had little technology to disrupt, the event caused widespread communication failures. Telegraph operators reported electric shocks, machines worked without power, and fires broke out. If such a storm occurred today, the effects would be catastrophic. Experts estimate that a modern Carrington-scale event could cause trillions of dollars in damage, knock out power grids, cripple GPS and communication satellites, and disrupt air traffic, banking, and emergency services. Recovery could take weeks or even months. Elon Musk sounds the alarm. SpaceX CEO Elon Musk raised concerns following the May 2024 solar storm, posting a striking graphic illustrating the toll it took on Starlink, his satellite-based internet constellation. The intense solar activity pushed the Starlink satellites to their operational limits, triggering protective shutdowns and system load surges. Musk emphasized that while we were lucky this time, a stronger event could disable or destroy entire constellations of satellites, potentially leaving vast regions without internet or communication access. The implications are staggering. A dense field of zombie satellites, non-functional, tumbling debris, could threaten other spacecraft and satellites, compounding the risks of orbital collisions and turning low Earth orbit into a dangerous junkyard. What are solar storms and why are they so dangerous? Solar storms are caused by flares and CMEs, which release streams of electromagnetically charged particles, mainly protons, electrons, and heavy ions, into space. These particles interact with Earth's magnetic field and atmosphere, producing both beautiful and dangerous effects. Auroras are the visible result of these particles being trapped and funneled toward the poles, where they collide with molecules in the upper atmosphere. These collisions produce dazzling displays of green, red, purple, and blue light. However, beneath their beauty lies danger. These same particles can fry sensitive electronics in satellites, induce electrical currents in power lines, leading to transformer failures, disrupt GPS systems, aviation communications, and radio transmissions, affect pipelines, making them more vulnerable to corrosion, pose serious risks to astronauts and high-altitude flights over polar regions. The most dangerous aspect of a solar storm is the speed with which it arrives. While light from the sun takes about 8 minutes to reach Earth, high-energy particles from an extreme CME can take as little as 15 to 30 minutes. This leaves minimal time for warnings or protective actions. Are we prepared?
To a degree, yes.
Modern satellites are equipped with radiation-hardened electronics and protective mechanisms to withstand solar flares. Power companies are also implementing safeguards such as grid segmentation, voltage suppression equipment, and real-time monitoring systems. The International Space Station, ISS, has designated radiation shelters for astronauts, and mission planning avoids spacewalks during solar flare warnings. However, much of our infrastructure remains vulnerable, particularly older power grids and communication systems that were not designed with space weather in mind. In 1989, a relatively moderate geomagnetic storm knocked out power to the entire province of Quebec in Canada, leaving millions without electricity for 9 hours. It's a stark reminder of our exposure. Governments and space agencies worldwide are now investing more into space weather forecasting, including advanced solar observation satellites like NASA's Solar Dynamics Observatory, SDO, and ESA's Solar Orbiter. The hope is that by detecting warning signs like sunspot activity and coronal instability, we can gain precious hours of lead time. Solar cycles and magnetic reversals. The Sun follows an approximately 11-year solar cycle, alternating between solar minimum, low activity, and solar maximum, high activity. We are currently in solar cycle 25, which reached peak intensity earlier than expected, raising concerns among scientists. One particularly ominous sign is the apparent magnetic reversal occurring on the Sun, where the Sun's magnetic poles flip. This phenomenon typically accompanies increased flare and CME activity. If the reversal is more intense or chaotic than usual, it could result in prolonged and stronger solar storms, a worst-case scenario for Earth's technology-dependent society. Nature's paradox, harmless yet threatening. Interestingly, solar storms do not harm humans directly. The particles don't penetrate the atmosphere or affect biological organisms on Earth's surface. The real danger lies in their ability to cripple the technology we rely on for survival. From global navigation systems to satellite internet, from banking networks to emergency services, nearly every facet of modern life is intricately tied to electromagnetic systems. A sudden collapse could be catastrophic, especially if recovery takes longer than our systems can tolerate. Looking ahead, what can we do? To mitigate the risks of solar storms, humanity must modernize power grids with improved shielding and fail-safe mechanisms, harden satellites against radiation and include automatic recovery protocols, establish real-time monitoring of solar activity with global warning systems, educate the public and industries about solar risks and emergency procedures, foster international cooperation, as solar storms affect the entire planet, not just one region or nation. Ultimately, the sun gives us life, but it can also challenge our civilization like no other force. Solar storms are not a question of if, but when. The May 2024 event, coupled with the activity of AR 3664, is a wake-up call. We must prepare now or face the consequences later.